Alright, this video is part 2 of a piecewise function or piecewise relation video series. Part 2, we're going to talk about how do you take a piecewise graph, or graph that might be chopped up into parts, and form a piecewise function out of it. The biggest thing you need to remember is that all piecewise functions are formed with two major parts: the formulas or the functions, and the constraints. The constraints can actually be written before you ever even decide what your formulas are going to be. The constraints are basically the limited domains. That's what we're going to do, is chop up our domain into a bunch of smaller parts, the constraints. So if we're taking a look at this, in red, you'll notice that our line, as far as x is concerned, only exists from -1 and to the left. So we can immediately say that x, for our red line over here, will only be less than, and notice open circle right here, it doesn't actually exist at -1, so only less than -1. Whereas if we're talking about the blue line, on the other hand, it's going to start at -1, and x will be greater than or equal to that, but also it ends over at 2. So x will need to be less than or equal to 2. Notice solid circles on each end, so or equal signs on our symbols. Finally, the green line is going to begin over at x is 2. So x will be greater than, it only goes to the right of 2. And again, open circle at the beginning of the line, therefore no equal sign. After that, it just comes down to a matter of how do you write the equation of a line. And you'll notice that since we have points at -4, -2, and at -1, 0, we can use those 2 points, or just judge off the graph, how to write a y equals mx plus b equation of a line. So we can use that to judge the slope. Notice we went up 2, right 3, so that would be a slope of 2/3 times x, and then we need to judge our y-intercept. Now, because our red line doesn't cross the y-axis, and because it doesn't seem like it's going to cross at a nice point, this would be a great time to use a little bit of algebra. So we'll say that, yeah, but it does look like it's going to be positive. I would say plus, but we don't know what b is yet. So let's go ahead and use one of our points, such as -1, 0, and say, well, when y is 0, with a slope of 2/3, x would have been -1, and we would have been adding that on to b. So I can say, well, -2/3, let's add that to the other side. Looks like b should have been approximately 2/3. So let's go ahead and write in 2/3 up here. Now, for the blue line, we can see that it's crossing basically on the y-axis up at +1. And you'll notice that if we follow that 1 to the right, 2 down, 1 to the right, 2 down, 1 to the right, 2 down, we will end up at that exact point over there at 2, -3. So I would say that that's a nice number there. So we've already figured out that we're going right 1, down 2, which is a slope of rise of -2, run of 1, times x, and we're crossing at a y-intercept of 1. And there is our equation, given our constraint, somewhere between x is -1 and 2. Finally, our green line looks like we've got a slope of 1. If I go upright, 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 we're going to cross through 5, 5. Starting at, it looks like 2, 2. So we can judge that to have a slope of 1. And notice if we just follow that, since that's a nice easy slope of 1, if I went down and left, it looks like we would have been going through the origin. And we could say +0, or basically have a y-intercept of 0. That's all 3 of our formulas with all of our constraints written, and there is one large piecewise function describing that red, blue, and green graph. I hope that helps you with piecewise functions. Good luck, and on to part 3.